this lesson, we'll be looking at physical and chemical changes and properties. When we look at a physical change, what we see is that the chemical structure does not change. If I looked at ice, which is solid water, I see H2O molecules. When I go to liquid water, as that melts, I still have H2O molecules. Nothing has changed about the chemical structure of the compound. When I look at chemical changes, what I see is that we actually see changes in how the atoms are connected to one another. So the connections, so the bonds between those atoms are different. In this case, so if we're looking at propane like you would use on a grill, the compound is C3H8, which reacts with oxygen to produce CO2 or carbon dioxide and H2O or water. We see that the bonds have changed. We have different atoms connected to each other. They don't all have to change, but something has to change when we have a chemical change occurring. Does a chemical change occur when water is boiled? And the answer to that is no. When we look at liquid water, it's H2O molecules. When we look at gas phase water, it's H2O. Even though we're putting energy in, we're not putting in enough energy that we can break a bond. And as a result, we still have H2O molecules. So this is a physical change. Let's look at some examples of physical and chemical changes. Remember that in physical changes, we don't have a change in the chemical composition. Some examples of this include mixing substances, separating a mixture. So we saw the iron and sulfur that were mixed, and we used a magnet to pull out the iron. That's separating the mixture. That's a physical change. Any type of phase change is going to be a physical change. So solid, liquid, gas, any combination of those. And a physical deformation. So if we cut something, bend it, stretch it, tear a piece of paper in half, it's a physical change because we haven't changed the molecules that are making up that piece of paper. For chemical changes, remember bonds have to be broken and formed. Not all of them have to, but some of them have to change. So examples are combustion, so burning something, decomposition or breaking things down, synthesis, where we make new compounds. All of those are examples of chemical changes. In addition to physical and chemical changes, we have physical and chemical properties. So they are associated with the change that is happening. So for example, color, density, solubility, so how much of something will dissolve in a solvent, melting point, texture. All of those things are physical properties. We don't have to change the chemical composition of it to be able to identify those properties. For chemical properties, we do have to change the identity of that substance. It has to undergo a chemical change in order to measure or determine these properties. So flammability, how easy something catches on fire, we have to set it on fire. Heat of formation, so that's the energy it takes to produce something or the energy released when something is formed. We have to have the reaction happen. The reactivity, does it react with an acid? Does it react with a base? Toxicity, how does it interact with whatever species it's in to be toxic? There has to be a chemical reaction happening there. Label each of these as a chemical or physical change. Melting iron is a physical change. We're changing from a solid to a liquid, so we're not changing the chemical composition. Rusting iron is a chemical change because we're actually changing the composition of the substance. We're going from iron to interact with, which is reacting with oxygen to form iron oxide. Combustion of methane is a chemical change. We start with one compound, which is methane. It's going to react with oxygen to form carbon dioxide and water. Making a sandcastle is a physical change because we're not actually changing anything about the chemical composition of the sand. We're just moving it around. Dissolving salt in water is a physical change. So we're not actually changing the composition of the water or the salt. In fact, we can boil up the water and recover the salt from that mixture. Digestion of food. This is actually a chemical change because our foods are processed by our body, starting with the enzymes in our saliva as it works through our digestive tract. And so it's actually undergoing a chemical change so that we can get glucose for energy out of that food.